Morning students. Today we start with our next module, which is the fourth module, which is on nanomaterial and characterization techniques. In the last module we have studied different type of the powder metallurgy techniques as well as the polymers, different types of polymers which are used in additive manufacturing process. And in the same way, for the powder metallurgy, we use a metals which is in the form of a powder form of the metals. So how to convert those metals to the powder form in terms of nanomaterials? To convert a material to the nanomaterials, we are having different procedures to carry out this. In the same way, when we take an example of polymer, from polymers we can make a nanomaterials. So to convert in terms of a nano, we come across different type of the techniques which are used for the making nanomaterials, what we call it as by using nanotechnology. So in our fourth module, we study about nanomaterials and characterization techniques. The materials which are manufactured, those are being characterized by using different types of characterization techniques. By using optical microscope technique, or it may be the scanning electron microscope, or it may be the transmission electron microscope, or it may be the electron probe micro analyzers. Like this, we are having different type of the techniques which are used for the characterization techniques. So here we are having a syllabus which we are going to have in our fourth module. So the first topic, which is of introduction to nanomaterials, that is a nanotechnology, how actually the nanotechnology has been emerged, what to mean by the bottom up and top down approaches and challenges in nanotechnology. Next topic, which is synthesis of nanomaterials and processing. So how to make nanomaterials? We are having a different process for making the nanomaterials and its processing. That may be by using wet chemical synthesis, or it may be the salt gel process, or it may be the gas phase synthesis of nanomaterials, or it may be the spray pyrolysis, or it may be the gas condensation processing, or it may be the chemical vapor condensation techniques. So these are the techniques which are used to convert material to the nanomaterials. In the same way, for the characterization techniques, we are having optical microscope, or SEM, what we call it as scanning electron microscope, TEM, that is transmission electron microscope, X-ray diffraction, scanning probe microscope, atomic probe microscope, electroprobe microanalyzer. These are the topics which we are going to study in our module 4. First, I'll start with the introduction to the nanotechnology. So what to mean by nanotechnology? So this figure indicates some of the structures which are related to the nanotechnology. So here we are having a figures which atom linkages, molecule linkages, which we are going to see in the same way. So today we study what to mean by this nano and technology. So a nanometer is a unit of length in the metric system equal to the 1 billionth of a meter, that is 10 raised to minus 9. So 10 raised to minus 9 is nothing but a nano, which is a meter. And technology is the making, usage and knowledge of tools, machines and techniques in order to solve a problem or perform a specific function. That we call it as a technology. So making or usage and knowledge of tools, machines and techniques in order to solve a problem or perform a specific function, that is called as a technology here. So nanotechnology is the study of manipulating matter on an atomic scale. On an atomic scale, if we are going to manipulate, that we call it as a nanotechnology. Nanotechnology refers to the construction and engineering of the functional system at very micro level, or we can say it as an atomic level. So if we are going to study with respect to the micro level and atomic level, then we call it as a nanotechnology. A nanometer is 1/1000th of a meter, roughly the width of 3 or 4 atoms. The average human hair is about 25,000 nanometers wide. That we call it as a nanometer. The history begins with the famous professor of physics, Dr. Richard P. Feynman. The first ever concept was presented in 1959 by this famous professor. The one line which is told by Richard P. Feynman is, there is a plenty of room at the bottom. That is nothing but from the bottom level, that is from the micro level or from the nano level, we can make a different type of the materials. So that we call, so invention of the scanning tunnel microscope in 1981 and the discovery of fluorescence, that is C60, in 1985 leads to the emergence of nanotechnology here. The term nanotechnology had been coined by Taniguchi in 1974. The early 2000s also saw the beginning of commercial application of nanotechnology, although these were limited to the bulk application of nanomaterials. The silver nano platform for using silver nanoparticles as an antibacterial agent, or nanoparticle based transparent sunscreens and carbon nanotubes for strain resistant textiles. For these we use nanomaterials. So you can see here macro, micro and nano level. The first what we see, it is with respect to the macro, which we are having 2 billion of nanometer, that is a person with 6 feet tall, which is 2 billion nanometer. What we see like that, it is a macro and it is micro and the nano. In the nano we are having 1 nanometer, or it may be the 2 nanometer, 1.3 nanometer thickness or diameter of a carbon nanotube. So it is a minute particles what we see, that we call it as a nanoparticles. So we are having a timeline that is from 2000, 2005, 2010, 15 to 20. Like this, when we see the generation of the products which we are going to see, in the first generation of the products where passive nanostructure, dispersed and contact nanostructures we have, that is aerosols, colloids, or product incorporating nanostructures, coating nanoparticles, or reinforced composites, nanostructure, metals, polymers, ceramics. These are the first generation products what we have seen in the 2009, 2005, active nanostructure, bioactive health effects, that is targeted drugs, bio devices, physico-chemical active, that is the transistor, 3D transistors, amplifiers, actuators, adaptive structures. These all are the active nanostructures what we have seen. In 2010, the third generation, that is the system of nano systems, that is guided assembly, 3D networking, and new hierarchical the architectures, robotics, evolutionary. All these come under the second framework now, that is of third. And in 2015 to 20, that is the molecular nanosystem. So what today we are going to see is from the how to manufacture the nanoparticles. The nanoparticles are manufactured from the micro level, that is from the molecular level we are going to manufacture. So molecular devices by design, that is atomic design or emerging functions. So from the molecular level we are going to manufacture the materials here. So from the molecular, from the base, from the molecules, we are going to make by using a free assemble of these molecules to make a material. That what we are having, the fourth generation, that is a molecular nanosystem we are having. So tools and technology. There are several important modern developments we are having. The atomic force microscope, AFM. So these are the modern tools which we are going to use for the nanotechnology. The scanning tunnel microscope or the scanning probe that launched a nanotechnology. Various techniques of nanolithography, such as optical lithography, or it may be the X-ray lithography, dip pen nanolithography, or electron beam lithography, that is we are using in inkjet printers, were also developed. So lithography in the what we call it as microelectronic mechanical system context is typically the transfer of a pattern into a photosensitive material by selective exposure to a radiation source such as light here. So lithography which is with respect to the typically the transfer of patterns into a photosensitive materials. So the patterns which are converted by using a photosensitive material by selective exposure to the radiation source such as sunlight. So here what we are going to see the figure, it is nothing but the lithography, where it is having a laser, it is having a cantilever deflection system, the AFM, it is having a AFM, that is atomic force microscope it is having, and the sample is at the bottom. So typically by the pattern, by transferring this pattern into a photosensitive materials by selective exposure to the radiation of sunlight here, source such as light. So from the source of a light, the pattern is been transferred here. So that is what we are having a technology, what we call it as lithography. Next we are having the carbon nanotube. So today's topic, what we are having a nanotechnology, in that we are going to see first in the line of the when we see nanotechnology, the nanotubes plays a very important role. So carbon nanotubes are electropics of carbon with a cylindrical nanostructure. It is having a cylindrical nanostructure. They have length to diameter ratio. When we see a length to the diameter ratio of up to that is 132.0000001, what we see, that is what we are having, that is a billionth, the 1 billionth of the length to its diameter ratio we are going to see here. So the nanotubes are members of the Fullerene structural family. Their name is derived from their long hollow structures with the walls formed by the one atom thick sheets of a carbon called graphene. So from the graphene sheets, that is from the graphite form of the sheets, from that we are going to convert to the thin thick sheets of the carbon, one atom thick sheets of a carbon, that is converted, and we are going to make a nanotubes. So which is having a high resistance material which we are having. So highest strength to weight ratio helps in creating lightweight spacecrafts we are going to see. So from the nanotubes we are having very good applications we are having nowadays by using the nanotubes. So easily penetrate membranes such as cell walls, that is helps in cancer treatment. We are having electrical resistance changes significantly when other molecules attach to themselves to the carbon atoms, helps in developing sensors that can detect chemical vapors. So from these nanotubes we can make the sensors that will detect the chemical vapors, that what it is having for the nanotubes. So nanotubes, we are having examples that is we can use, that is Aston Bell Sports, using CNT, that is the carbon nanotubes, in making bicycle components. We are going the company, that is the Aston Bell Sports, they are using these nanotubes, carbon nanotubes, for making bicycle components. In the same way, these are used in lightweight boards which have been manufactured by using Zavex technologies. Zavex technology is using the carbon nanotubes which are used for manufacturing the lightweight boards. In the same way, we are going to see that is replacing transistor from the silicon chip, as they are small and emits less heat here. So replacement of transistors is by CNTs. And in the same way, we are having in electrical cables and wires. We are going to see the carbon nanotubes in solar cells, and in fabrics. In fabric also we are going to use the carbon nanotubes. In the same way, we are having a nano rods, that is quantum dots. The quantum dots, that is nano rods, are one morphology of nanoscale objects. Dimensions ranges from 1 to 100 nanometer. They may be synthesized from metals or semiconductor materials. They are manufactured by using semiconducting materials and metals. A combination of ligands acts as a shape control agents. These are the shape control agents and bond to different facets of the nanorod with a different strength. These allows different phases of the nanorod to grow at different rates, producing an elongated object here. So these are used as an nanorods. So when it is activated, it gets elongated. The objects get elongated. So these are used in smart materials. These are used in making smart materials. So in display technologies, because the reflectivity of the rods can be changed by changing their orientation with an applied electrical field. So what I have told, these are used in the smart materials for making a smart materials. That is, when the input of electricity is there for these material, it changes its shape. It changes its shape and orientation. When the electricity is removed from these materials, then automatically regains its position. So these are used in micro electromechanical systems. These are used in micro electromechanical systems and in cancer therapies. Nanobots, nothing but nanorobots. So these nanomaterials which are used in nanorobots, close to the scale of 10⁻⁹, largely in R&D phase. Nanobots of 1.5 nanometer across, capable of counting specific molecules in a chemical samples. Since nanorobots would be microscopic in size, it would preferably be necessary for very large number of them to work together to perform microscopic and macroscopic tasks, capable of replicating using environmental resources. So these are used in detection of toxic components in environment, in drug delivery, biomedical instrumentation. So for all these we are going to use the nanobots. Approaches in nanotechnology. So we come across two types of the approaches here. One we call it as bottom up approach and top down approach here. So bottom up approach is nothing but from the molecular level we are going to have a assemble of them to form an material here. So in bottom up approach, different materials and devices are constructed from molecular components of their own. They chemically assemble themselves by recognizing the molecules of their own breed. So here from the molecular level or from the atomic level, by the assemble of these atoms or molecules which are framing the nanomaterials here. So from the level of molecules or from the atoms of their own, they form the structure which we call it as a nanomaterial. So here we are having example of molecular self-assembly or Wattstone-Crick base pairing or nanolithography technique. What we are having, these all are by using the bottom-up approach what we are having. In the same way we are having a top-down approach. In the top-down approach, that is from the bigger components, we are going to make in terms of a smaller nanomaterials what we call it as a top-down approach here. So in top-down approach, nano objects and materials are created from large entities without bouncing its atomic reactions. Usually top-down approach is practiced less as compared to the bottom-up approach. So it is a nanotechnology what we are having. From the bottom-up approach, that is from the base of the atomic or from the base of the molecules, we are going to make an entities here. So that is what technologies we are having. So in powder metallurgy, we used to see that the material are converted to the powder form. That is by the larger entities, the larger material which will be converted to the smaller powder metals by using the ball mill or by using the chemical methods or by using the physical methods. By using physical methods, we used to make metal to the powder form. That is what we call it as a top-down approach what we are having. From the bigger or larger entities, we are going to convert it to the nanomaterials. That what we call it as the bottom-up approach here. So solid state techniques, what we are having, solid state techniques, that is what we have told you. By using solid state techniques can also be used to create the devices known as nano electromechanical systems. So I have told you the example of the ball mills, or I have told you example of chemical conversion. By using physical methods, we have converted the material to the nano or the powder form. So that what we call it as a solid state techniques what we are having. We can use this technique for making the nano electromechanical systems, or NEMS, which are related to the micro electromechanical systems, or MEMS. So MEMS became practical once they could be fabricated using modified semiconductors. So these materials, nano materials, which we are going to use in the semiconductor device for fabricating technology, normally used to make electronics. So these materials, when we use in the semiconductor device, that are used in the most of the application of the electronics. So here we are having some of the metals which are used for different purposes or the application here. So the zinc oxide, which is used as a dirt repellent, hydrophobic, or cosmetic and stain resistant. So for cosmetic and stain resistance, we use the zinc oxide, or else dirt repellent, for dirt removal we use the zinc oxide. So most of the cosmetics, in cosmetics we see the zinc oxide, and in some of the material which are used for the cleaning purpose, there we see the dirt repellent, that is the zinc oxide. So in the same way we are having silver ion. So silver ion, which is used in the healing property. So most of the paramedicals what we are having for in the creams we see the silver ion for the healing property. For the healing property it is having. So these are used in those creams which are used for healing the wounds. There we use this silver ion. In the same way we are having aluminum silicate, which is used as a scratch resistance. So when we are see the scratch resistance, it is on the metal, or it is in the body of the cars, or it may be the body of the vehicles. There we use the aluminum silicate for the removing the scratches here. So that is the application of aluminum silicate. Gold ion, that is for making chip for fabrication or drug delivery, we use the gold ion material. So application of nanotechnology, when we see the nanotechnology in terms of the application, when we take an example of different applications, we use in a variety of fields. So from the energy to the fabrics. So here energy, it may be the medicine and drugs, or it may be the nano biotechnology, or it may be nano devices, optical engineering, defense and security, bioengineering, cosmetic, and nano fabrics. For all these we use the nanotechnologies. So when we take the small the fabric material, for fabric also we use the nano materials. So that is what we are having today of the nanotechnology. So nanotechnology, which is used in drugs, that is for curing of the cancer. So provide a new option for drug delivery and drug therapies. Enable drug to be delivered to precisely the right location in the body, and release drugs doses on a predetermined schedule for optimal treatment here. So delivered to the precisely the right location, that is this drug which has to be delivered to the right position or the right part of the body. It has to locate. For that we use the nanotechnology for a predetermined schedule for optimal treatment. Attach the drug to a nano-sized carrier. So for the nano-sized materials which are used for the attachment for this, they become localized at the disease site, that is cancer tumor. So where actually the part which has been attacked by a cancer, for that part the material or the drug has to circulate, or it should reach that portion. To reach that portion we use these nano materials for the movement of these in the bodies. So here they release medicine in that kills the tumor here. So when it reaches to that portion, it kills the tumor. And in the same way, current treatment is through radiotherapy or chemotherapy. So we are having a radiotherapy or chemotherapy by which the material, that is the nanomaterial, which moves to the right position of the cancer part, and it kills the tumor there. So for the movement in the human body part, these nanoparticles are used for that purpose. That is, these materials are used for the radiotherapy or chemotherapy. So nanobots can clear the blockage in arteries. So for the clearing of the arteries, for this we use the nanomaterials or nanobots that are used for the clearing of the blockages in the arteries. So the figure which indicates here the movement of the nanoparticles in the body, the first figure and the second figure, what we are going to see here, those are nothing but the movement of the the first figure which indicates the movement of nanobots to the clearing of the blockages in the arteries, and the second figure which indicates the movement of the material to towards the cancer part of the body to kill the tumor here. So that is the figure which indicates here. So in the same way, this nanotechnology which is used in fabrics for the fabric purpose, that is in the textile areas, we use these nanotechnology. The properties of familiar materials are being changed by manufacturers who are adding nano-sized components to conventional materials to improve the performance here. For the improvement of the performance, we are going to use these performance. We are going to use the different type of the nanomaterials or nanotechnology for the fabric. For example, some clothing manufacturers are making water and stain repellent clothing using nano-sized whiskers in the fabric that cause water to bead up on the surface here. So that is, by using a nano-sized whisker materials, they are going to make stain repellent, and by using the water and stain repellent cloths they are going to manufacture by using this nanotechnology. In manufacturing the bulletproof jackets, for making a bulletproof jackets, they are going to use the nano materials or the nanotechnology which is used for manufacturing. In the same way, the spill and dirt resistance, antimicrobial or antibacterial fabrics, for making the antibacterial fabrics or antimicrobial and spill and dirt resistance, for making these we are going to use the nanotechnology. So where actually all these are used is when, because of the soldiers who are in a different area, the dresses should not get the bacterial content. At that case, we are going to use antibacterial fabrics we use, as well as antimicrobial we use, and spill and dirt resistance we are going to use in that areas. In that areas we are going to use these nanotechnology. So bulletproof jacket, spill and dirt, or the stain resistant, all these fabrics which are manufactured for a different application, that is, for it may be for the soldiers, or it may be say for the persons who goes to the different areas, dependent on the climate, or it may be the environments. For those purpose they are going to manufacture by using the nanotechnology. So in mobiles we are having a nanotechnology. So when we take an example of the charging wires, or it may be the earphones, whatever we see, those all are by using the nanomaterial. So nanotechnology concept developed by Nokia Research Center and the University of Cambridge, UK. So the morph which will be super hydrophobic, making it extremely dirt repellent. So extremely for the dirt repellent, they are going to make, and it will be able to charge itself from available light source using photovoltaic nano wire glass covering its surface. So it is one of the technology what we are having by using the photovoltaic nano wire glass. By using it self charges, it going for self charges, and nanoscale electronics also allows stretching. Nokia envisaged that nanoscale mesh of fibers will allow our mobile device to be bent, stretched and folded into any number of conceivable shapes. So for a different bends, for making a different bends, opening and closing of the mobiles, what we see, all these are manufactured by using the nanomaterials. So in electronics we use the nanotechnology, that is electrodes made from nanowires enable flat panel display to be flexible as well as thinner than current flat panel displays. So for making nanowires we are going to use the nanotechnology. Nanolithography is used for fabrication of chips. For manufacturing of the chip in electronics, we use nanolithography technique. Transistors are made from nanowires, are assembled on a glass or thin film of flexible plastic. So in the figure 3, what we are going to see is the placement of transistor. The placement of transistor of nanowires are made in terms of nanowires. Transistors which are made in terms of nanowires, and they are placed on a thin sheet, glass sheet, that is a flexible plastic. On flexible plastic we are going to place a transistor which are made in terms of the nanowires. E-paper display on sunglasses. E-paper display on sunglasses and map on car windshields. So e-paper displays on sunglasses and map on car windshields. So e-papers are manufactured by this nanotechnology. In computers, the silicon transistors in our computer may be replaced by transistor based on carbon nanotubes. Carbon nanotube is a molecule in form of an hollow cylinder with a diameter of around a nanometer, which consists of pure carbon. Nanorods is an upcoming technology in the display techniques due to less consumption of electricity and less heat emission. Size of the microprocessors are reduced to greater extent. Researchers at North Carolina State University says that growing arrays of magnetic nanoparticles called nanodots. So this techniques which is going on right now. So in computers also we are going to use the nanotechnology. So the HP is developing a memory device that uses nanowires coated with titanium dioxide. With the titanium dioxide, we are going to the HP has having a memory device. They are manufacturing one memory device by using the nanowire coated with titanium dioxide. One group of these nanowires is deposited parallel to another group. When a perpendicular nanowire is laid over a group of parallel wire at each intersection, a device called a memoristor is formed. A memoristor can be used as a single component memory cell in an integrated circuit. By reducing the diameter of the nanowires, researchers believe memoristor memory chip can achieve higher memory density than flash memory chip. Magnetic nanowires made of an alloy of iron and nickel are being used to create dense memory devices. So magnetic nanowires made of an alloy of iron, nickel, and are being used to create dense memory devices. So for these nanomaterials are chips produced by Intel before I series processors were between 65 nanometer to 45 nanometers. Later, with the help of nanotechnology, 22 nanometer chips were made, which itself is a milestone. So the advantage of using nanotubes is faster and smaller. Carbon nanotubes can be used to produce smaller and faster components. This will also result in computers that consume less energy. High speed and high capacity memory. allows circuits to be more accurate on the atomic level. So we are going to use this nanomaterial for cutting tools made up of nanocrystalline material such as tungsten carbide, tantalum carbide and titanium carbides are more wear and erosion resistant and last longer than their conventional counterparts. So for these we are going to use in terms of nanomaterials for the wear resistance materials. It is a wear resistance. These all are the wear resistance material. So to resist the material wherever we want in an application, we use these as a nanomaterials. Silver nanocrystal have been embedded in bandages to kill bacteria and prevent infection. So silver ion, which we are going to use in the creams for pharmaceutical, that will kill the bacteria and prevent infection. So nanoparticulate based synthetic bone formed by manipulating calcium and phosphate at the molecular level. So synthetic bones are being made. Aerogels, lightest known solid due to good insulating property. Aerogel is one of the material which is used nowadays in aircraft parts. That is because it is a solid part. Aerogel is nothing but a solid part. It is having a good insulating properties and is used in a spacesuit and are proposed to use in spacecrafts. So in India, by the IIT Mumbai is the premier organization in the field of nanotechnology. In IIT Mumbai, they have done one of the research work. They have done one of the research work on nanotechnology. Research in the field of health, environment, medicines are still on. Starting in 2001, the government of India launched the Nano Science and Technology Initiative, NSTI. So then in 2007, the Nano Science and Technology Mission 2007 was initiated with an allocation of ₹1,000 crores for a period of 5 years. The main objective of the Nano Mission are basic research promotion, infrastructure development for carrying out front-ranking research, development of nanotechnologies and their applications, human resource development and international collaborations. For all these, they have allocated 1,000 crores of rupees in 2007 for the period of 5 years. So what they have done by the IIT Mumbai, that is for making nanomaterials which are used for the wastewater treatment and water disinfection. So to make this, they have taken one of the project on this water treatment and water disinfection. So by using the water treatment purpose as well as water disinfection, they have done one of the project based on this for the purpose by using nanomaterials. By using nanomaterial, they have done the project here. So synthesis and purification of nanomaterial, characterization of nanomaterial by the sorption or disinfection, degradation. By these methods, they are by using silver and copper nanoparticles for water disinfection as well as carbon nanomaterial for sorption of heavy metals, for purification of heavy metals as well as for the disinfection. They have used these materials by that is the nanoparticles for this project. So what are the possibilities of the future? Nanotechnology may make it possible to manufacture lighter, stronger and programmable materials that require less energy to produce than conventional materials. So they are lighter, stronger and programmable materials what we are having. So these require less energy to produce than conventional materials, and that promise greater fuel efficiency in land transportation, ship, aircraft and space vehicles. So the further of nanotechnology could very well include the use of nanorobotics. So these nanorobotics have the potential to take on human tasks as well as tasks that human could never complete. The rebuilding of the depleted ozone layer could potentially be able to be performed. So it can be used in the rebuilding of the depleted ozone layer that could potentially be able to be performed. So these are the possibilities of the future. There could be an entire nanosurgical field to help cure everything from natural aging to diabetes to bone spurs. There could be almost nothing that could be repaired that is eventually so for the curing of for the surgical field, to help cure everything from natural aging to diabetics to bone spurs, we are going to use nanomaterials. There could be almost nothing that could be repaired eventually with the introduction of nanosurgery, so which cannot be done eventually or repaired, that can be done by using nanosurgery. So this is an example what we are having of this. But what are the disadvantages? What are the disadvantages or the pitfalls of nanotechnology? So nanoparticles can get into the body through the skin, lungs and digestive system, thus creating free radicals that can cause cell damages. So nanoparticles can get into the body through the skin, or it may be lungs, or it may be the digestive system, thus creating free radicals that can cause cell damage. Once nanoparticles are in the bloodstream, they will be able to cross the blood-brain carriers. So this is the main pitfall of nanotechnology, that is, they can damage the parts here. So once nanoparticles are in the bloodstream, they will be able to cross the blood-brain barriers. As well as the most dangerous nano application used for military purpose is the nano bomb that contain engineered self-multiplying deadly virus that can continue to wipe out a community, country, or even a civilization. So nano bomb, that is a self-multiplying deadly virus that can continue to wipe out a community here. As well as nanobots, because of their replicating behavior, can be a big threat for Grego. So here it is a replicating what it is having, nanobot, that is a replicating behavior what it is having. So because of these all are the pitfalls what we are having for the nanotechnology. So this is our first session on this module 4. So in our next session we'll continue with what do mean by bottom-up approach and top-down approaches. Thank you.